Hi technical guys, very good day for everyone. Welcome back to Budget Power Electrical Solution. Today, we're going to explore another very important topic in electrical engineering, power factor. But this is not just about memorizing a formula. By the end of this lesson, you will understand what power factor really means, why it matters in an industrial electrical system, and most importantly, why we don't simply keep power factor at 1.00, even though we are taught that 1 is perfect. So stay with me, because by the end of this video, you'll have a much clearer understanding of power factor and how it actually works in the real electrical world. Let's imagine we have an electrical generator supplying power to an industrial facility. Let's say this generator is rated at 100 kVA. So, what does this 100 kVA actually represent? Think of it as the total apparent power that the generator and the electrical system are handling. What makes up this power? Now, this total apparent power is related to two important components. First, we have real power, measured in kilowatts, or kW. This is the power that actually performs useful work, for example, turning a motor, producing heat, or operating electrical equipment. Then we have reactive power, measured in kVAR. Reactive power is associated with establishing the magnetic and electric fields required by equipment such as motors and transformers. And together, these are related to what we call apparent power, measured in kVA. Our 100 kVA example. 100 kVA, 80 kilowatts. PF equals 80 divided by 100 is equal to 0.8. Narration. Now suppose our industrial system is using 80 kilowatts of real power. The generator is supplying 100 kVA of apparent power. So our power factor is real power divided by apparent power, 80 divided by 100, which gives us a power factor of 0.8. Now imagine power factor equals 1. 100 kVA equals 100 kilowatts. Power factor equals 1.00. Now let's imagine the ideal situation. Suppose our 100 kVA corresponds to 100 kilowatts of real power. Then our power factor is 100 divided by 100, which equals 1. So yes, power factor of 1 is theoretically ideal. So why don't we simply keep every industrial system at 1.00? But now let's make this example more realistic to understand our question. What happens when we connect actual industrial equipment to this generator? For example, an induction motor. Induction motor consume kW mechanical work, kVAR magnetic field. An induction motor cannot operate using real power alone. It needs real power, or kW, to produce mechanical work at the shaft. But at the same time, it also needs reactive power, or kVAR, to establish the magnetic field inside the motor. So as soon as this inductive load is connected, the generator is supplying not only real power, but reactive power as well. And now our perfect 100 kilowatts from 100 kVA condition begins to change. Because some of the electrical system capacity is now associated with reactive power, the apparent power becomes greater than the real power. Therefore, the power factor falls below 1. So now, we can clearly understand the main idea. A power factor of 1 is theoretically ideal. But when an induction motor is connected, the motor needs kW for useful mechanical work and kVAR to establish its magnetic field. That is why, in a real industrial system, power factor naturally falls below 1. Thank you for watching Budget Power Electrical Solutions. If this lesson helped you, don't forget to give it a thumbs up, subscribe to the channel, and leave your comments below. Keep learning, keep improving your technical knowledge, and I'll see you in the next lesson.